So we'll finish talking about the average rate of change. Remember, we need 2 data points to talk about rate of change over time. So here we have time in hours, and here we have speed in miles. So this is the function s of t. So if we want to find the average rate of change, or the speed that we were traveling from mile 1 to mile 4, then what we're going to do is we're going to take the difference in the y values and divide that by the difference in the x values. We want the difference of our outputs, so here specifically our s of t's, and the difference in our inputs. Again, here we're talking about t values. So we're going to find our average rate of speed by taking s of 4 minus s of 1 over the t value of 4 minus the t value of 1. So we need 2 data points. Remember, we need 1 s of 1 and we need 4 s of 4. Those are 2 points of data that we can find the slope of the line that contains those 2 points, and the slope equals the average rate of change. So we're looking for the slope of a line. So it's the change in independent variable over independent variable. So here the average over this 3-hour period would be s of 4, which is 200, minus s of 1, which is 50, over 4 minus 1, which is 3. So it would be 150 over 3. So there is our average, and that's miles per hour. So the miles per hour would be our units, and that will go in there 50 times. So 50 miles per hour. So let's look at another example. We'll try to find here. Let's just talk about, in general, the average rate of change. This is where we're looking for the change in range values divided by the change in domain values. So if we have 2 points, A, f of A, there's one data point, and we have another point, B, f of B, then we're looking for the slope of the line that contains those 2 points. That's going to be our average rate of change. So that's why this looks like the slope formula, because that is what that's going to be. It's going to be f of B minus f of A over B minus A. So not necessarily just in the context of talking about speed, we can talk about any rate of change. So let's look here at this function. Here's the function f of x equals the quantity x minus 3 squared. We don't know what it models, but we know algebraically we can still find an average rate of change for this function over any 2 sets of points on that function. So here we have f of 1 and 1. We also have f of 3 and 3. So there's the 2 data points that we want to find the rate of change through. So we need f of 3 minus f of 1 over 3 minus 1. F of 3 we can see from the graph, or we could find it analytically. F of 3 is 0. F of 1 appears to be 1, 2, 3, 4. And then the difference, 3 minus 1, is 2. So this average rate of change is the slope of this negatively sloped line, so we shouldn't be surprised that we get a negative value. Let's look at these 2 values. So we have 4 f of 4, there's 1 point on the graph, and we have 7 f of 7 is another point on the graph. So we're looking at f of 7 minus f of 4 all over 7 minus 4. There's the average rate of change. So f of 7 appears to be 16. f of 4 is 1, and 7 minus 4 is 3. So that's 15 thirds, or 5. We don't know what the units are. We're not given units here. But if we were, it would be the units of the dependent variable over the units of the independent variable. So there we are. We've talked about just basic fundamental functions from probably pre-algebra, and we've talked about average rate of change. So come to class next time and we'll do some homework problems.